Welcome folks. In this video we are going to look at the science paper 2, which is chemistry, and we are dealing with the paper that was written by the external candidates, and this paper is from 2019. Now let's look at the first question from question 1 from section A. So question 1 reads 50 cubic centimeter sample of alcohol is mixed with 50 cubic centimeters of water. Now the volume of the mixture is found to be 97 cubic centimeters. Which of the following is the best explanation for this observation? So now the key point here is, if we are to add these two volumes, we are expecting to have the total volume of the solution to be 100 cubic centimeters. Now what happened is, after they added these two liquids, the volume gave them a 97 cubic centimeters. So the question is, where is the remainder of 3 cubic centimeters? So what explanation can we give in order to satisfy the reduction in volume? So here we look at the first multiple choice. A, some alcohol molecules evaporated. No. Then B, alcohol molecules fit into the gaps between water molecules. So this is the answer. So the reason why there is a reduction in volume whenever you mix water and alcohol, some of the molecules for alcohol will fit into the gaps between water molecules. Then we can now move on to question 2. A mixture Q contains 3 compounds, T, U, and V, whose solubility in ethanol and water as shown in the table below. So we can now begin with T. Our T, we can see that it's very soluble in ethanol, sparingly soluble in water. Then U, insoluble in ethanol, very soluble in water. Our V, insoluble in both these two liquids. Then how would you separate the mixture Q to obtain the pure crystals of compound U? So the whole thing is, we want to get U. Now let's look at U. So for U, we can say that the U is insoluble in ethanol but very soluble in water. So what are we supposed to do? So let's take it, for instance, we have this mixture where we have our T, then U, and also V. What are we supposed to do? What is the first step that we are supposed to do? And remember, the focus is we want to remain with U. So what we are going to do is we are going to first add ethanol. Why are we adding ethanol? So that the T can dissolve. So after this T has dissolved, U and V will remain in solid particles because these two are insoluble in ethanol. So then after we dissolve this one, what are we going to do? We are going to filter. What is the importance of filtering? The importance of filtering, we want to separate our T from U and V. Then after we've filtered, so we can see that now the mixture consists of 2. In this mixture we have V, we also have U. Now let's look at between the two. For us to form crystals, the U must be dissolved in a solution. Now let's look at V. V is insoluble in both water and ethanol. So after we filter, we are going to add water. Then after we add water, we know that our U will dissolve. Then if U is dissolved, how can we separate a dissolved solution from an insoluble solution? So we are going to filter. Then after that, U will undergo crystallization. So our answer here is just C. Then we move on to question 3. Question 3, the chemical formula of ammonium sulfate is. So what is the chemical symbol for ammonium? So ammonium is NH4 with a valence of 1. Then sulfate is a radical with a valence of 2. So if we use this crisscross method, this will give us NH4, then we have our 2 here, then sulfate here. So this is our final answer, and we can see that the answer is C. Then the atoms P with the mass number 31, the atomic number 15, and S, the atomic number 16, and the mass number of 32 have the same. So the keys have the same. So let's look at P. So from P, we can see that here we have 15. So this means that there are 15 protons. So we have 15 protons. What of electrons? So the electrons are also 15, minus 15. Then let's look at our S. Our S will have 16. So there are 16 protons in S. There are also 16 electrons in S. So we can see that the protons differs with the protons in P differs with the protons in S. The electrons in P differs with the electrons in S. So these two cannot be the answers. So now let's check for number of neutrons. Now how do we find the neutrons? So we need to take the difference between the mass number and the atomic number. So let's find the number of neutrons in P. So this will be 31 minus 15. So this will give us 16. Then for S will be N is equal to 32 minus 16, also give us 16. So we can see by calculation that these two elements have the same number of neutrons. So our answer is just C. Now we move on to question 5. Which pair of elements can combine chemically to form single covalent bonds? So covalent has to do with the sharing of electrons. Then ionic has to do with the transfer. So for us to have ionic bonding, we know that we need to have a metal and a non-metal. So B and D, these two cannot be the answers. Now the key point here is we want to have a single bond. So how can we determine that an element will form a single bond? So we need to look at the valence number. So if you look at oxygen and carbon, oxygen has a valence of 2. Then carbon has a valence of 4. So oxygen can make double bond. Carbon can make 2 double bonds. Now we want a single bond. Now if you look at hydrogen, hydrogen has a valence of 1. So and if we are to draw the chemical formula for ammonia, which is NH3, this is the single bond that we are looking for. So whenever you are looking for a single bond, you may have information about hydrogen. So the answer here is just A. Then question 6. Which one of the following is not an example of a mineral acid? So sulfur is a mineral acid because it's a strong acid. So is nitric, sulfuric acid. So the only organic acid here is citric acid. So this is not a mineral acid. Now move on to question 7. Lead to iodide is a yellow insoluble salt. So the whole thing is about insoluble salt. Which of the following should be reacted with lead to nitrate solution to produce lead to iodide? Now what is the concept behind the formation of insoluble salt? So the whole thing is about first you need to have 2 reactants that are soluble. So let's take it for example, you need to have 2 soluble salts. So soluble plus soluble, then we'll have the insoluble salt that we want to make, then plus the soluble salt. So among the products, we need to have the insoluble salt and the soluble salt, because for us to separate an insoluble from a soluble, we can use filtration. Now here this insoluble salt we are given, so we are looking for lead iodide. This is the soluble salt that we are looking at here. Then the question is, we need to make sure that the 2 reactants that we are selecting each reactant must at least have one ion that will be present in the insoluble salt. So the first point here is we are going to get lead. So say lead nitrate. Why? We know that lead nitrate is a soluble salt. Why? All nitrates are soluble in water. So from lead nitrate, our interest is just lead. Then from the other salt that we are going to get, we need to make sure that there is iodide, so that this iodide will now combine with lead to give us this. So that's a key point. Then the metal that should do bond to this group 7 element to give us a soluble salt must be from group 1. So it can be sodium, lithium, or potassium. But from the multiple choices, we can see that there is one answer that has a potassium. So we need a potassium here, so that we are going to have a double displacement here. So the potassium will now displace lead to give us the potassium nitrate. Remember, all nitrates are soluble, so we're able to get this soluble salt. So that is the concept. So the answer here is D. Zinc hydroxide can react with sodium hydroxide because it is. So if you look at hydroxide, we know that most of the hydroxide are bases, and here is a base. Now if the zinc hydroxide can react with a base, so therefore zinc here is acting as an acid. So what oxide behaves in such a manner? So this is what we call an amphoteric oxide. Then we move on to question 9. Question 9 reads, calcium burns in oxygen according to the following equation. And we are lucky that we are given a balanced equation, so no need of balancing it. But in a case where the equation is not balanced, you are supposed to balance it. Now, if 5.2 grams of calcium burns completely, what will be the mass of calcium oxide produced? So 5.2 grams is for calcium. Then for calcium oxide, we don't have, so we put X. So we are going to find the molar mass for each of these two compounds that we are interested. So there is one compound or one substance, one element whose mass is given, and the other substance whose the mass we are looking for. So that is our focus. Now, if you go on the periodic table, you find that the mass number for calcium is 40. So now for here we can say that this is not a compound, it's an element. So this 40 will multiply with the number in front. So we can say that we have a 2 in front. So 2 times 40 will give us a 80. So this is 80 grams per mole as the molar mass. Then we need also to find the molar mass for calcium oxide. Now let's find the mixture. So we can see that from the chemical formula for calcium oxide, there is 1 atom of calcium plus 1 atom of oxygen. So we can now do the substitution. Mass number for calcium is 40 multiplied by 1, then 16 times 1. So 40 times 1 is 40 plus 16. So we'll find that this will give us 56. Now remember, there is also a 2 here. So this 56 will now multiply by 2, and this will give us 112 grams per mole as the molar mass. So this is what we are going to put here. Then after this, we can now cross multiply. So we have 80 grams per mole times X is equal to, so say 5.2 times 112. So I'm getting 582.4 grams per mole, then times the grams. So we can divide by 8 grams per mole, even here by the same. So that if we cancel we can cancel this, we'll cancel this. So what is 582.4 divided by 80? So my final answer that I'm getting is 7.28. If I were to round it off, correct to one decimal place, I'm getting 7.3. So our answer here is just B. Then question 10. Barium sulfate is best prepared by. So barium sulfate is an insoluble salt. Then what is the best method for you to prepare an insoluble salt? So we use precipitation. We go to question 11. The order of the reactivity of the elements below, starting from the least reactive, is. So we want to start from the least reactive. Now let's look at the first one. So the first one has a valence of 1 because there is only one electron in the outermost shell. Here we have a valence of 2, a valence of 4. We can see that we have 1, 2, 3, 4. Then here we have a valence of 1. So the least reactive is this element Y, because it is the element with the highest number of electrons in the outermost shell. Now for element X and Z, these are coming from the same group of the periodic table, which is group 1, since they all consist of 1 electron. Now between the two, we need to look at which one is the most reactive. Okay, so now we can see that the least is Y followed by Z. Then we are going to have X. So X is the most reactive element. Why? Because we can see that in X we have 3 shells. In Z we only have 2 shells. So in a case where the 2 or more elements have the same number of electrons in the outermost shell, if you want to identify the most reactive, you need to look at the one with the most number of shells, because we know that in group 1, as we move down the group, their reactivity series increases. So also as we move down the group, the number of shells increases. So that is the key point. So the answer is YZX. YZX. So our answer is just C here. Now we can move on to question 12. Which of the following explains the importance of catalyst in a chemical reaction? So the whole catalyst thing is about reducing the activation energy. So A, enable the activation energy to be lowered. So this is the answer. Then 13. An element was described as shown in the table below. Which description is correct about the element at RTP? So we'll look at the first one, number of shells. We can see that we have equal number of shells. Then valence, here we have 4, 3, 6. Then 5. Then period it is in period 5, 3, period 6, then 3, group 3, then 6, 3, 5. So let's analyze these numbers. Let us analyze these numbers. So the answer here is C. Number of shells 3, valence 6, period 6, then group 3, the state is liquid. Then which of the following sets corresponds to a metal and the main ore from which it is extracted? So the first one, zinc from calamine. So this is the answer. I know most of the ores that we know about zinc is zinc blende. So I want you to know that a calamine is also a ore for zinc. because if you look at B cannot be the answer. Iron, bronze is an alloy. Copper, magnetite is an ore for iron. Then aluminium, hematite, no. So that is the answer here. Then question 15, which of the following observation most strongly suggests that a solid element X is a non-metal? A solid element X is a non-metal. X reacts vigorously with chlorine. X is a conductor of electricity, no? Forms an acidic oxide. Has more than one valence. So a non-metal can form an acidic oxide like sulfur. So the answer is C. Then we move on to question 16. Nitrogen is used to produce ammonia as shown in the diagram below. Then what is X? So if this is the nitrogen, we're just looking at the reactant, the other reactant that reacts with nitrogen to give us ammonia. So that is hydrogen. This is under Haber process. Then we move on to question 17. A thin C2H4 burns completely in air to form carbon dioxide and water. What is the balanced chemical equation for the reaction? So for this one, let's say C2H4 plus CO2. You know that the combustion will give us the carbon dioxide plus water. So let's put it, so for here we'll put 2 here, we also put 2 here. So you know that here we are going to have 4 atoms of hydrogen, 2 atoms of carbon. Then let's look at the total atoms of oxygen. So 2 times 2, here we have 4, then 2 times the one here we have 2. So we can see that on the product side there are 6 atoms of oxygen. So we need to put a 3 here so that we are able to get the same. So which one is our answer according to that? So our answer is D. 18. The organic product of the reaction between this and this is. So let's look at the first one. So this is methane. Methanol is an alcohol due to the presence of hydroxide. Then this one is methanoic acid. Is an acid because of the Cu. So whenever an alcohol reacts with the methanol, we are going to get an ester by the process of esterification. So let's look at how can we come up with the product. So say CH3 or H is reacting with the HOOC H like this. So I've just reversed this so that we know that during the formation of an ester there will be formation of water. So from the alcohol we get hydrogen, then from the acidic party we get the hydroxide so that we are able to form the water molecule. Then the remaining party will just connect this. So this is CH3 or CH. So we need something like this. So what is our answer? So the answer is B. You can see that this is the same as this. It's just the reverse. Okay, so now we can move on to question 19. Choose the correct monomer for pterylene. So for pterylene, we have alcohol and carboxylic acid, amine, ethene. So the answer is A. So we need to have an alcohol and a carboxylic acid for us to produce pterylene. And remember, pterylene is produced by condensation, polymerization. Then question 20. The displayed structural formula below are of different compounds. Which ones are isomers? So I want to look at the isomers. So first look at the chemical formula for each. So we can see that here we have 1, 2, 3, 4. So 4 atoms of carbons. Let's look at hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here there are 10 atoms of hydrogen. Let's check for W. We have 1, 2, 3, 4. So 4 atoms of carbon. 1, 2, 3, 4, 5, 6, 7, 8. So 8. Okay, let's check for X. We check for, so we have 1, 2, 3, 4, 4 atoms of carbon. Hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10. So you can see that the molecular formula for X is the same as the molecular formula for V. That is according to the definition of isomers. So we are looking at molecules with the same molecular formula. So the isomers here are, it's V and X, which is B here. Okay, so now we are done with our section A. So let's now dive in section B. The table below shows some common gases and their particulars. So the first one, we have gas: ammonium, carbon dioxide, carbon monoxide, helium, nitrogen. The relative molecular formula mass, we have these numbers. Vapor density. So the vapor density tells us how heavy and the ability of a gas to be able to diffuse at a given rate in air. Choose from the list given the gas or gases that best suits the following description. A gas may be chosen once, more than once, or not at all. So for A, Roman number 1, the gas that diffuses fastest. So if you want to know or determine the gas that has the ability to diffuse fastest, you need to look at the gas that is the lightest. So how do you know that this one is the lightest? You need to look at the gas with the smaller, or in fact we can say the smallest relative molecular mass. So that is the key. So from the table we can see that the gas with the smallest relative molecular mass is helium. So we can see that here we have a 4. Even the vapor density is also very small. So the answer here is helium. Then the names of the gases that diffuse at the same rate. For gases to diffuse at the same rate, they need to have the first one, same relative molecular mass and also same vapor density. So let's look at nitrogen. So nitrogen has 28, carbon monoxide has 28, vapor density is 14, also here is 14. So these two gases will diffuse at the same rate. So it's carbon monoxide and nitrogen. So that's a key point that we are looking at here. Now we can look at question B. Set the name of the gas that will diffuse faster than any other gas shown in the table. So the lowest in terms of relative molecular mass is 4. So which gas can have the lower number than 4? So if let's look at hydrogen with the mass number of 1, also here 1. So let's make it diatomic. So if we make it diatomic, we'll say 2 times 1. So here the relative molecular mass is 2. So hydrogen is considered to be the lightest, even though it was not one of these gases. Now we can go to question C. What is the relationship between relative molecular mass of a gas and its vapor density? Let's go back to our table. So I want you to focus on the first one, relative molecular mass for each given compound or element. So look at the first one, 17. 17, then its vapor density is 8.5. Then relative now increases to 44. Then look at the relative density, which is 22. So the key point is here, you can see that the greater the relative molecular mass, the higher the vapor density. Or we can see that the vapor density is directly proportional to relative molecular formula mass. This means that if the relative molecular formula mass increases, the vapor density will also increase. So that is the point here. So the relationship is that we'll say relative molecular mass is directly proportional to vapor density. Or if you want, you can also say the greater. So if we can also say the greater the relative molecular mass, the higher the vapor density. Now, question D, under what condition would carbon dioxide diffuse faster than ammonia, both of equal volumes? So if you look at carbon dioxide, the molecular mass is 44. Now for ammonia, that is 70. Now, how can we make a gas that is heavier than the other one to diffuse at a faster rate than the gas that is lighter? So what can we do? So what we can do here is we can just make sure that we apply heat to carbon dioxide. We know that if the gas is heated, it becomes lighter, and as a result it diffuses at a faster rate. So say by heating carbon dioxide, or by increasing the temperature. So the other point that we can get here is whenever you increase the temperature of a gas, you also increase its speed in terms of diffusion. Now we can move on to question 2. The diagram here shows the preparation of liquor in a village. Okay, so we can analyze. We have fire, then a mixture of ingredients, we have support, then A, okay, cold water, B, then our liquid liquor is here. Then name the process demonstrated above. So this is the fermentation process. Now so that we get now the full answer, then this fermentation process is involving fractional distillation, because we need to separate water from alcohol, so fractional distillation is also involved. Now name the apparatus B. Now here, this is the vapor. Now we want this vapor to be converted back to liquid. So the function of B is to convert this vapor back to liquid. So B is just a condenser, because condensing means to change a gas back to liquid. So we have a condenser. Then 2, if this experiment was done in the school laboratory, what name would be apparatus A and B? So apparatus A, this can be rounded bottom flask. Then for B, this can be Liebeck condenser. Okay, so now C, what is the scientific term for the liquor or liquid in the experiment? So the scientific term is ethanol. So this is the alcohol that is being produced. And remember, ethanol is the only alcohol that can be produced by fermentation according to science. Now we move on to question 3. Aluminium metal was reacted with aqueous copper 2 sulfate. Construct a balanced chemical equation for the above reaction, including state symbols. So we have aluminium plus copper 2 sulfate. Now, according to reactivity series, aluminium is more reactive than copper. So the copper will be displaced, and this will give us aluminium sulfate plus copper. Now let's convert this into chemical symbols. So aluminium is Al, solid, plus copper sulfate is an aqueous. This is a soluble salt. Then we get aluminium. Now remember, aluminium has a valence of 3. Then sulfate has a valence of 2. So if we use this, we are going to have Al2 SO4 enclosed in brackets, then a 3 here. Plus copper. We have to balance it. So we need a 2 in front of aluminium on the left side. We need a 3 here so that this 3 can affect the sulfate, since there is a 3 here. So we also put 3 here. So this is our balanced chemical equation. Then for B, deduce an ionic equation. So that's what we want now. We want to deduce an ionic equation. So now, whenever you are trying to look at an ionic equation, we are going to break every compound that is in aqueous phase only. So begin with this one. So say 2Al. We are not going to put any charge. This is in solid state. Plus then copper sulfate is in aqueous phase. So say 3Cu. Then the valence is 2, since we have copper 2. Then aqueous plus then we are going to have 3SO4 aqueous. This is minus 2. Then aluminium, we have positive 2. So this aluminium now, this time, we have a positive charge since it's in aqueous. This is in aqueous phase here. So positive 3 in aqueous. Then these 2 here must be written in front. Plus SO4 aqueous 3, this 3 here. Then minus 2 plus 3Cu. We are not going to put the charge. Now from here we can now look at the spectator ions. So spectator ions are those ions that are not doing anything. Or how do we know that these are spectator ions? We need to look at the ions that are in the same phase. So let's look at aluminium. Aluminium on the reactant is a solid, on the product is in aqueous. So this is not it participated in a reaction. Copper did the same, but sulfur did not do anything. So this is a spectator ion. So our overall ionic equation will be 2Al solid plus 3Cu aqueous. Then we get 2Al plus 3Cu solid. So this is our final answer. Now, sometimes you may be asked questions like, is this reaction, is it a redox reaction or not? So this is a redox reaction, and for redox reaction, you can use this to remember. So we have what we call a Lioga. So Lioga, the first Leo is L for loss of electrons, means oxidation. So the substance that has lost electron or electrons, that substance is said to be oxidized. Then Ga, this will be gain of electron or electrons. So this is the reduction or reduced. So from this, let's look at copper and aluminium. So which one of these two gained and which one gave? So I know it may not make sense. You may think, how come a metal is receiving? Yes, here there is that gain. You can also look at the charge. Here the overall charge for aluminium is 0, but here we can see that the overall has increased. Then here we can see a positive 2. Here we can see a 0. So whenever the oxidation number increases, that substance is said to be oxidized. So aluminium undergoes oxidation, copper undergoes the reduction. Now let's look at this concept of the one gained, the other one gave or donated. How is this possible? Now if you go back to the way things were, we know that copper at first it was with calcium sulfate. Now when this was bonded, we know that whenever we are looking at the bonding between a metal, which is copper, and a non-metal, which is sulfate here, there is this ionic compound, ionic means of attaining stability by the copper gave this when it was in a compound. So when this aluminium is coming to displace copper, so what happened to copper is when this copper is leaving this position, it has to receive, it has to get back its electrons that it gave sulfate. So that's a key point we are saying it gained. So it has to, like, it says like, okay, give me what I gave you. Since you are taking this position, let me have my electrons back. So that is the kind of gaining we are looking for. Then when for aluminium, upon reaching this position, it has to make sure that the sulfate must always be stable. That's why we consider the sulfate to be in as the spectator ions. So after the copper has been displaced, the aluminium now must make sure that it satisfies the sulfate. So that's the kind that we are looking for. And if you want more of these, you can just write in the comment section below, as I can make a video based on reduction and oxidation. Now we can go to question B4. Below is a list of substances which are either deliquescent or hygroscopic, and some of which are not. Aluminium hydroxide, calcium oxide, sodium hydroxide, sulfuric acid, anhydrous calcium chloride, anhydrous copper 2 sulfate, iron 3 oxide, and sodium carbonate. From the list given above, choose one substance which is a deliquescent. Now what is a deliquescent? A deliquescent can or is defined as a substance that absorbs so much moisture, which is so much water, from the atmosphere, and after absorbing that, the same substance, it dissolves in the absorbed water and forms a solution. Now from this, which substance can behave like that? So the answer here is calcium chloride. You know how this behaves. It can absorb water and it dissolves. That's why you may find sometimes the salt will like stick together, forming a crystal. Then for hygroscopic, is defined as a substance that attract and hold water molecules from the environment. So which substance can do this? That is sulfuric acid. Then neither deliquescent or no hygroscopic, so that is aluminum hydroxide. Then what is the difference between a delicescent and hygroscopic? So a delicescent, we said it absorbs so much, and as a result it dissolves. Now we'll say a delicescent is a substance that changes its state after absorbing water. Wow. A hygroscopic does not change. This is in simpler language. While a hygroscopic is a substance that does not change its state after absorbing water. Then some substances are said to be efflorescent. What is an efflorescent? So an efflorescent is just a substance that can lose its water or crystallization to the surrounding. So say this is a substance Okay, so that is the answer there. Then we move on to question 5. A learner reacted a certain mass of magnesium with 150 cubic centimeters of dilute hydrochloric acid. 240 cubic centimeters of hydrogen gas evolved at RTP and pressure. Then construct a balanced chemical equation. So this chemical equation is between a metal. So if a metal reacts with an acid, the products will be salt plus hydrogen. So that is the concept you need to have here. So what is the metal? The metal is magnesium. This magnesium is reacting with hydrochloric acid. Then from the hydrochloric acid we get chloride. So the name of the salt begins with the metal. Then from the acid such as this one, you get chloride. If this was sulfuric, you get sulfate. Nitric, you get nitrate plus hydrogen. Now let's write in chemical symbols. So we have Mg, S, solid, plus C. Acids are in aqueous phase, so you put aqueous here. Magnesium chloride. Magnesium has a valence of 2. Chlorine is in group 7, has a valence of 1. So this will give us magnesium chloride aqueous plus hydrogen. Remember, hydrogen must be diatomic. So we can now do the balancing. So we need to put a 2 here so that we have 2 atoms of hydrogen. Also here 2 chlorine also. So we have done the first thing. Then B, calculate the number of moles of hydrogen in 240 cubic centimeters of the gas. So what is the formula? Since we are told room temperature and pressure, the formula for number of moles is equal to volume of the gas over molar volume. Now, before you do calculations, make sure that the volume of the gas must be in decimeter cubic. Now here, it's in centimeter cubic, so we need to convert. 1 cubic decimeter is equivalent to 1,000 centimeters cubic. So we put our 240 here where we have cubic centimeters, then x we cross multiply. So the whole concept is just that whenever you are converting from centimeter cubic into decimeter cubic, you just have to divide by 1,000. So that's a concept here. You divide by 1,000. So what is 240 divided by 1,000? We know that this will give us 0.24 decimeter cubic. So we'll say 1 decimeter cubic is equal to 1,000. So if you are converting from decimeter to centimeter, remember to multiply by 1,000. Then the reverse is also true. If you are converting from centimeters to decimeter, you divide by 1,000. So that's a concept here. So this time now we can see that we have our volume is 0.24. Then what is the volume of a gas at RTP? So it is just 24. So now we can do the mathematics here. So 0.24 divided by 24. So the answer is 0.01 moles. So these are moles of hydrogen. Remember this. Then Roman number 2, the mass of magnesium used in the experiment to produce 240 cubic centimeters of hydrogen at room temperature and pressure. So what's the formula for mass? The formula for mass is equal to N multiplied by molar mass, given that we make M the subject of the formula, but the actual formula is number of moles equal to mass over molar mass here. So this tells us that we need the number of moles of what? Magnesium. So how can we find the number of moles of magnesium? So we need to look at the mole ratio for hydrogen, because we have the number of moles for hydrogen. Then we'll use the moles for hydrogen to find the moles for magnesium. So let's look at the number in front of hydrogen from the balanced one. So you can see that there is a 1 here. Then from magnesium, there is also a 1. So whenever you have two compounds or elements with the same mole ratio, just know that the number of moles will also be equal. So the number of moles of hydrogen will be equal to the number of moles of magnesium, since these two, they share the same mole ratio. So we'll put 0.01, then multiply by the molar mass. Magnesium is just an element, so we just have to get the mass number. So on the periodic table, I have 24 as the mass number. So what is 24 times 0.01? So I'm getting 0.24 grams as my final answer here. Now we move on to question 6. Start the two diagrams below showing different sizes of sodium metal. So here in A we have like a larger size, then here we have smaller size. So these atoms are of the same compound or same metal, which is sodium. Then for A1, which diagram would the sodium react faster if put in a beaker containing water? So it's diagram B. The reason is we know that the smaller sizes of particles react faster than the larger particles. Because if you look at the reaction according to science is all about the collision of atoms. So it is easy for a small atom to collide with another small atom compared to large atoms. And we looked at also the molar mass. We said the atoms with the smaller sizes or small molar mass, they are easy to move compared to something that is heavy. So say this is because, so say because diagram B has smaller sizes of particles, and according to the factors of reaction, we know that the smaller the size of the particles, the faster the rate of chemical reaction. Then for B, state one other factor that can affect the rate of this chemical reaction. So if we want to increase the rate of a chemical reaction, other than considering the size, we can also increase the temperature. So the temperature will give the kinetic energy of the particles so that they are able now to move at a faster rate. Also, by adding a catalyst, this also may affect this reaction. Then state the effect of a catalyst on the activation energy. We know that it lowers, that's the effect. So it lowers the activation energy. Okay, then we move on to question 7. Below is a skeleton diagram of the periodic table. Then A, give the name of the region marked X on the periodic table. So these are known as the transition metals or elements. They are also known as the group B elements. Then give N2 general properties of the elements found in the region marked X. So the properties for metals, the first one we can say they conduct electricity. Then apart from conduction of electricity, they are good conductors of heat. Then we also have some other general properties, like they have high densities. Then also they have high melting and boiling point. You can also put those points. Then for question C, state any two uses of the elements found in the region marked X. So we can say, like, we know that iron is a transition element, and iron is used in the Haber process as a catalyst. So we can say they are used as a catalyst. So they are used as a catalyst. Okay, so that is it. So catalyst. Then we can see that some of these metals, they are used in constructions. They are used in constructions. So there are so many uses of transition. Like apart from constructions, we can also consider some of these. They are used to make cooking utensils. Then we also have cardboard parts, then aeroplane parts. Then some of these are used in apart from this, we can say they are used in to make electric cables in terms of wiring. So now let's move on to question 8. Generally, some metals easily corrode when exposed to certain conditions. Now, what is our first question here? Explain what is meant by corrosion. So whenever we look at corrosion, it's just a wearing or just the destruction of a metal due to some environmental conditions. So let's now define this as we'll say corrosion is a natural process which converts refined metal to their more stable. But don't worry about the definitions that you come across. The whole thing is, if you know the definition that you know is okay, that's okay. Then B, which of the metals, zinc, potassium, or copper, corrodes fastest when exposed to certain conditions? So the answer here is potassium. How did you know that this is potassium? Because potassium is the most reactive. So the most reactive elements are the most metals or elements that corrode fast. Give two conditions that easily promote corrosion. Then the first one will say atmospheric oxygen, then also atmospheric water vapor, which is just water. Then give two methods of preventing corrosion of metals. So the first one we know by painting. So we can prevent corrosion by painting. You know that painting will prevent water and oxygen from reaching the metal. Then also by galvanizing. Apart from galvanizing, also greasing, oiling, sacrificial protection. All these are methods that we can use to prevent corrosion. Then we can go to question 9. Carbon is asymmetrical and exists in many forms of allotropes. Question A, what are allotropes? So say allotropes are different structure forms of the same element that exist in the same physical state. So this is one of the definitions for allotropes. Then B, give two crystalline allotropes of carbon. We have diamond. Then we also have graphite. Then for C, give one property and the use based on the property of one of the allotropes you have named in B1. So let's get graphite. So say it is greasy and soft. So because of this, it is used as a lubricant. Okay, so we are done with our section A. Let's go to section C. Answer any two questions from this section. Write your answers in the separate. Okay. Now here we'll just share one or 2 points. The equations below shows the thermal decomposition of the nitrates of 3 metals represented by W, X, and Y, not their real chemical symbols. Okay. Then A, which one of the 3 metals is the most reactive? So the most reactive is X. Then the reason the most reactive decomposes only partially. So we can say that it only a partial that decomposes. It didn't give us a complete. So say because it decomposes partially. Then list reactive. Give a reason for your answer. So W, you can see that W here, there is just this W, so this decomposes fully. So because it decomposes completely. Then which one of the three elements is likely to be sodium? So it's X, since we said it's very reactive. And remember, most of the carbonates or maybe nitrates of the stable elements do not compose, and if they do, they just decompose partially. Then which one of the elements of the three metals is more reactive than zinc? More reactive than zinc. We know it's X, because we can see the reason is still the same. Give a reason for answer. Because of the decomposition. So X, because it decomposes. It decomposes partially. Remember, most metals, they decompose partially to heating. Then less reactive than zinc. So the one who is W, because whenever you decompose zinc will give you zinc oxide, nitrogen dioxide, and this. So whenever there is this oxide, it means that there is a certain percentage of oxide that is not decomposed. Now here we can see that it decomposes completely because there is no oxide. So because it decomposes completely. Then for question, then D, state the chemical test for oxygen. So we say it relights a glowing splint. Then we move on to question 2. 8.0 grams of impure hydroxide solution reacted with exactly 40.0 cubic centimeters of 2.0 molar per decimeter cubic sulfuric acid. So from this 80.0 grams, this means that there is a certain percentage that was pure and a certain percentage that was impure. Okay, so from this mass there should be a certain mass for impurity. So this is not the mass for sodium hydroxide. There should be some substances that we consider to be impure. Now let's look at the first reaction here. Write the balanced chemical equation for the reaction including state symbols. So sodium hydroxide is a base. Then we have this acid here. So we are looking at the reaction between a strong base and a strong acid. So this will give us a neutralization reaction. So the chemical formula for sodium hydroxide is this one. Then we will have aqueous plus sulfuric acid is this one. Then also aqueous. Then what are we going to do? So let's look at the chemical formula. Sodium has the valence of 1. Then sulfate has a valence of 2. So we can see that we are going to have sodium SO4 aqueous plus. We know that whenever we react a base with an acid, we get salt and water. So we have H2O. which is a liquid here. So we need to balance our chemicals. So let's begin by sodium. So we need to put a 2 here. So 2 atoms of sodium, 2 atoms of sodium. Then for oxygen, we can see that we have 2 plus here 6. So we need to put a 2 here. So at 2 times this we have 4. Okay, so now we have the equation that is balanced. Then for Roman number 2, construct a simplified net ionic equation for the reaction. Okay, so let's do this. 2Na plus, we'll break it since it's in aqueous, plus 2OH minus plus the sulfuric, these two will come here, aqueous, plus the sulfate minus, this will give us sodium plus aqueous, then what else, sulfate minus, plus water will not break it, it's in liquid state. So let's look at the spectator ions. So the spectator ions is sodium is the spectator, sulfate is also the spectator. So our final answer will be 2OH minus aqueous plus 2H aqueous, then we get 2H2O. Then since we are told that a simplified, we can see that we have 2 in front of each, so we can cancel this. Then our simplified will be hydroxide aqueous plus hydrogen ion, then we get H2O. Then for B, calculate the number of moles for sulfuric acid that reacted with 8.0 grams of impure sodium hydroxide. So for number of moles, we'll say, we know that number of moles is equal to, we have the concentration, so this will be concentration multiplied by our volume here. So the concentration is this number, so it's 2.0 mole per decimeter cubic times the volume is 40. Now remember, we need it in decimeter cubic, and we looked at this, so it's just 40 divided by 1000, so we get 0.04 decimeter cubic. So you can cancel this, we cancel this, so 0.04 times 2, so I'm getting 0.08 moles of sulfuric acid. So this is our answer. Then find the mass of pure sodium hydroxide from the impure solution that reacted with 4.0. Okay, so how can we find the mass? So we'll say, let's ignore that we don't have this mass here. So if we don't have this mass here, we know that the mass will be, mass is equal to number of moles times the molar mass. So how can we find the number of moles? Let's look at sulfuric acid. So sulfuric acid has a valence of 1. Then sodium hydroxide has a valence of 2. So let's use this relationship. So we'll say number of moles for, mole ratio for this, then to sulfuric acid. So the mole ratio for the number in front of sodium hydroxide is 2. The number in front of sulfuric acid is just 1. The number of moles for sulfuric acid is 0.08. Then here we put x, we cross multiply. So it's x is equal to 0.08 multiplied by 2. You get 0.16. as the moles of sodium hydroxide. So this is what we are going to put here. So 0.16 times, we need to find the molar mass for sodium hydroxide. So let's look at sodium hydroxide. So we'll say Mr is equal to Na times, here we have 1 plus oxygen times 1 plus hydrogen times 1. So sodium has a mass number of 23 times 1. Here we have 16 times 1 plus 1 times 1. 23 times 1 is 23 plus 16 plus 1. This is giving us 40. So we put 40 here. So 0.16 times 40, I'm getting 6.4 grams of now sodium hydroxide. And make sure the mass that you are calculating must be less than the mass of the substance that is impure, because from that you have the certain mass for that impurity. So you can't get a number that is greater than 8. Then that answer is incorrect. Then for D, determine the percentage purity of sodium hydroxide. So say percentage purity is equal to the actual yield, so which is the pure. So this is 6.4 over the mass, the original mass. What is the original mass? Is 8.0. So 8.0 times 100%. So let's do mathematics here. 6.4 divided by 8.0 is 0.8 times 100%. Our final answer is 80%. So this means that from 100% of sodium hydroxide, 80% is pure, 20% is impure. Now we can go to the last question. The series of processes below shows the links to the formation of an ester known as ethyl ethanoate. Then for A, from the reaction scheme above, name the processes K. So K is changing from ethene to ethanol. So this is hydration or hydrolysis. This is just the addition of water. Whenever you add water to an alkene, you form an alcohol. Then we go to L. L is showing us that we are moving from ethanol to ethanoic acid. So this should be oxidation. So we have oxidation. Then M is giving us from, this should be ethanoic acid, is an acid. So from ethanoic acid to an ester, this should be esterification. Okay, then for B, construct the chemical equation describing process K, including state symbols. So ethene is C2H4, which is a gas, plus we are adding water, a liquid here. Remember, the number of carbons will not change. Hydrogen must increase by 1. So from the ethene there are 4 atoms of hydrogen, we add 1, so this becomes 5. Then here you put OH, which is a liquid here. So for this one, it's already balanced. You don't have to struggle. They state both the chemical name and the common name for substance P. So it is, the chemical name is ethanoic acid. Then what is the common name? Acetic acid. State the general formula of the series where substance P belongs. So this is CN H2N plus 1, then Q. Give N2 uses of ethyl ethanoate. it is used in perfumes because esters have nice smells. Then also it is used as flavors in food. So this is what we can say for this. So this is what I can share for you guys with this paper. So thanks for watching.